Hey there, this is Tony, and today I'm going to show you some processing steps using Siril, StarXTerminator, and Photoshop. StarXTerminator is newly integrated directly into Siril, and so we'll run through those steps. And I'm going to process the Crescent Nebula, or NGC 6888. So with no further ado, let's get started. I've got my fits image already loaded into Siril. So this image is a result of a line and stack process that was performed in Siril. And you'll notice that I'm in linear mode here at the bottom. And so I'm going to switch over to what's called auto stretch. Click on that. And this is simply a view of the fits file. I'm not editing or changing the fits file by any means by just having this view in place. The first thing I want to do is there may be some sort of edge artifacts that are a result of the stacking process right on the outside edge of this image. So I'm going to do a very minor crop by holding down my left mouse button, dragging, and then right-clicking and going ahead and doing a crop. The next thing I want to do is you'll notice that there's somewhat of what's referred to as a background gradient. And what we mean by that is the dark areas here in between the stars and the dark areas over here on the top left in between the stars have a different, basically, background darkness. So we want to kind of even that out. The Crescent Nebula is a little tricky because there is just naturally some background gas nebula that is occurring in this object. But anyway, let's go ahead. So I'm going to click on Scripts, Python Scripts, Processing, and go down to what's called GraXpert Python. There are other ways you can do a background extraction in Siril. You notice up here is a thing called Auto BGE. It also does a background extraction, but for the purposes of this video, let's go ahead and use GraXpert. But I definitely encourage you to try out other methods as well. So we click on that. It's going to run the script, and then it's going to bring up a dialog box. And you see here, Operation, Background Extraction. I'm just going to use all the defaults for the purpose of this video. Click on Apply. And the process is now complete. So we can minimize this. And you notice that from what we had previously, the background darkness between the stars here on the bottom right and between the stars on the bottom left is a bit more evened out. The next thing we want to do is go to Tools and Astrometry and then Image Plate Solver. So what this does is it kind of tells Siril, it will give Siril some of the information about the object that we're looking at, along with some of the capture information. So on this, leave everything at default and click on OK. And you see here, it's contacting the server online, and then it's completed. And you notice here in the Siril command line boxes, some of the image information has been brought into Siril. The next thing you want to do is you want to do a color calibration. And so I'm going to go to Image Processing, Color Calibration, and then Spectrophotometric Color Calibration. What this does is it kind of gives a representation of the object as it might appear to, let's say, the human eye. And so on here, I've got my camera selected, which is using this chip, which is the Sony 571. I used a one-shot color camera with a UV and infrared block filter. Click OK. And you see here the color very subtly changed after doing that processing step. So now we're ready to do a star extraction. And you may ask yourself, well, wait a minute, why are we even doing a star extraction? Well, sometimes when you process your images, the stars can be a little bit overwhelming. In this particular capture, the scene conditions were pretty average. And so some of the stars may look a little bit bloated. Maybe if I zoom in using my mouse wheel here, you can see, look here, the stars are very, very slightly elongated. We'll fix that later on in this video. But that's why we're doing the the star extraction. So I'm going to go over to scripts, Python scripts, and you see here there's a folder called RC Astro, and there's a star exterminator. Now, there are other ways you can do star removal. You'll see here also in this dialog here is Cyclone. There's also another way that you can do it using StarNet 2.5 is another process. But again, for the purposes of this video, I'm going to go ahead and use RC Astro Star Exterminator, primarily because it's brand new integration directly into Siril. So click on that, run script, and it's going to open up a dialog box. I'm going to just accept all the defaults. So basically the defaults is create me an image with no stars, and then also generate a star mask image as well. So we'll run Star Exterminator. It's initializing. You can see it's using my graphics processing unit, which is an NVIDIA, and a pretty powerful one at that. It's a 5060. So the process runs at a pretty rapid clip. Now, if you're on a laptop or maybe a less powerful GPU, this may take a little bit longer. So let's go ahead and close this. And you see, voila, the stars are now gone. And we're looking at a starless image. Interestingly, you may go, well, hold on. There's some really weird artifacts here on the top here and on the bottom and over here as well. And that's just sort of the end result of doing this star extraction. It's not perfect by any means, but it does a pretty good job. The next thing I want to do is I'm going to go into a move out of auto stretch mode. So auto stretch mode, as I said at the beginning, is just a viewing mode. It's not changed the image. I want to go into what's called linear mode. And you see when I do that, everything kind of goes a little bit dark. And so what I want to do is go ahead and first of all, do a sharpening process on the image. So I can go to Python scripts, processing, and in this video, I'm going to use Cosmic Clarity. So I click on that. It runs a script. It will then bring up a dialog box. And I'm going to select Sharpen. I'm going to select Non-Stellar, because that's all I'm working on today for this particular image. And then just accept all the defaults and click on Run. And you see, once I do that, the progress starts to kick into gear. And again, fast GPU, which may or may not accelerate or make sure the process is running on a fairly rapid clip. And so it is now complete. I can minimize this. And if I go back into auto stretch mode, and if I zoom in a little bit and hold down my control button in Windows, left click, and I'm going to drag. So let's do a before sharpening, and then after sharpening. And you see there a very, very subtle change. The next thing you want to do is you'll also notice, wow, there's quite a few speckles here in the image. So we're going to go ahead and do a noise reduction. So I'm going to go to scripts, Python scripts, and then I'm going to go processing, and I'm going to use GraXpert again. But this time, when I run the script, it'll bring up a dialog box. And I'm going to select here, denoising. There are other tools. You can use, let's see here, Cosmic Clarity as a denoising tool. I believe, yes, there's a noise exterminator as well. But again, for this video, let's go ahead and use GraXpert for just for demonstration purposes. Click on Apply, accept the defaults, and then click on Apply. And then once it's complete, it's going to take quite a few seconds, which I forgot to say. This is a fairly intensive process using the GPU. And you can see here, it's moving along at about what? About 1% a second. So the process will take about another 40 seconds, 30 seconds. And while it's doing that, You notice that here in GraXpert, I may already mentioned the operation was selected as denoising. The model that we're using, or the AI machine learning model that we're using, or AI model, is this particular version. And then I've selected the strength here. Sometimes I've gone up to 0.7 on the strength settings on denoising, and a lot of it depends on really the scene conditions along with how many captures I took. For this image, which I forgot to say at the beginning, it's about 4 hours total, and each sub was about 5 minutes. And so that's what is that? That's about 48 times 5 minute subs to give us about 4 hours total integration time for this image. You can see that processing is complete. So I'm going to go ahead and minimize this, and then I'm going to click down here to give me full view. And then you can see that the noise is very, very subtly reduced in the image. So we've done let's see here, we've done a crop, we've done a plate solve, we've done a background extraction, color calibration, then we've done a sharpening, and then we've done a denoise. So that's the image that we have right now. Interestingly, you can see some of the outer nebula is starting to appear here. We've still got these weird artifacts that have appeared after doing the star removal, and we'll address that in a few moments. Now I'm going to go into auto stretch, into linear mode from auto stretch. And then what I'm going to do is another script. I go to Python scripts, VeraLux, and now I'm going to go into hypermetric stretch. Run that script, and this brings up another dialog. And I'm just going to select all the defaults here. So basically what hypermetric auto stretch does is it kind of takes away some of the work of having to do a manual stretch in your image. And a stretch is basically increasing the brightness, changing the contrast of your image to try and tease out some of the details in the nebula. And so if I click on live preview, you can see straight away, if I was to apply this hypermetric stretch, this would be the end result. I'm just going to keep all the defaults right now and click on process. And then after this is done, I will go ahead and close this. So it says completed, close, and you see the end result here. So again, we're now teasing out some of the details in this nebula. The next thing I want to do is maybe go into image processing, stretchers, and then a curves transformation. So what am I going to do here? So curves transformation is the ability, again, to sort of change the brightness and contrast in the image. And if I go to the bottom left here, and I'm going to click, and I'm going to drag this bottom thing just to the start of the curve, this sets the black point in the image. See what it did? And we don't want to go too far, because then we see this clip here where it says clip percentage. That means, wait a minute, Tony, you're going too dark on this image. So maybe just backtrack just a little bit around here. So it's 0.05%. I'll leave it like that for now, and then click on apply and close. So now, again, we've teased out some details. We've improved the contrast a little bit. There are other tools you can use. I've noticed in scripts, Python scripts, and VeraLux, there's a tool called Revela, which also you can use to work on some of the contrast. For the purpose of this video, we'll keep it simple. I encourage you to take a look at Revela if you wish, to tweak the contrast just a little bit more. So now what we can do is we can go ahead and we can save this image as a TIFF file. So I click up here, I select TIFF, and then let's just call this nebula. And click on save. We want to save it as a 16-bit TIFF. And the reason being is we're going to go into Photoshop after this to do some more tweaking. So click on save. Right, so that's the nebula part done. So now you may ask, okay, hold on. What about the stars part? So let's go ahead and let's open up the stars result from StarXTerminator. Double click. And so now you see the stars. And again, you'll go, okay, we're in linear mode. I barely see any stars here. And we're going to fix that. So let's go into image processing, stretches. And the first thing I want to do is what's called an async transformation. What this does is it does a stretch on the image, but it kind of retains some of the colors of the stars. And usually when I do this, I'll go anything from like 50 up to 300 on this number here. And I'm going to click apply, but then I'm going to do another stretch. I'm going to go to stretches, histogram transformation, and I'm going to move this slider, this middle slider, over to the left a little bit. And you see now I'm teasing out some of the stars just a little bit more. Click on apply and then close. And I'm going to save this image as a TIFF file. So TIFF, and let's just call this, let's call this stretched because it's stretched stars. There we go, stretched. Click on save, again, 16-bit and save. All right. So now we've got two TIFF images. We've got the nebula and we've got the stars. So let's go ahead and take a look at Photoshop. So the first thing I'm going to do in Photoshop is I'm going to open up that nebula TIFF file, double click. I'm also going to go ahead and open up the stretch stars. So we've got two tabs here, stars and nebula. I will remind everybody, I'm using Photoshop, but there's nothing to stop you doing the same thing that I'm doing in Affinity or in GIMP. I just happen to have a subscription to Photoshop. So let's do the first thing. So let's look at the stars, first of all. So I'm going to use my mouse wheel, scroll up to zoom in. And what I showed you earlier is, remember how some of the stars were kind of a little bit oval looking? So there's a trick in Photoshop. You can kind of alleviate that a little bit. So I'm going to click on this, the background layer here. Click on Control J to duplicate the layer. I'm then going to set the blend mode to darken. Then I'm going to go into filter, other, offset. And you see here, I've been playing around with this earlier, where I've set the vertical pixels down. But if I set this to 0, okay, so there's those oblong stars. Now I'm going to arrow down in this vertical box. 1, 2. See what happened on the stars? They become just a little bit rounder. Maybe I'll go to 3. Yeah, okay, 3, that works. Click OK. Now I'm just going to go ahead and I'm going to merge the layers. So let's go to layer and let's see here, merge down. So now I've got this more circular looking stars. I'm going to do Control A to select everything. Control C to copy. I'm going to go over to my nebula image and do Control V. I'm going to paste. So then you may go, okay, looks good, but I only see the stars. So the next thing you want to do is set the blend mode here, screen or linear dodge add. I'm going to use screen. And you see when I do that straight away, wow, look at that, the stars have appeared. I'm going to zoom in using my mouse wheel and kind of move around a little bit. And you see the stars have appeared nicely, and they're not overwhelming like they were in the previous, in the original image, excuse me. If I do Control 0 to go to 100% view, you can also see that we've kind of retained some of this background nebula that is around the Crescent nebula. And I don't want to lose that necessarily. But what I would like to do, maybe, is if I select the background layer, maybe I want to kind of emphasize the nebula a little bit more. So I've selected the background layer. I go into Filter, and I go into Adobe Camera Raw Filter. So this then brings up a new dialog for us. So this is the ACR dialog. And there's a few things I can do here. So I can, if I want to, I can set the saturation. I can go really crazy up to 100, which looks completely unnatural. Or let's back it off to about, let's say, around 15. And then there's also a vibrance setting, which kind of works on some of the contrast in the image. And again, I can go really crazy on the colors and saturation. Or let's just backtrack here. Let's take it to about 10. That might still be a bit of overkill. Let's maybe back off on the saturation here. And maybe take the vibrance just to 5. And then I can also, there's a clarity button here. So if I go all the way to the right on clarity, you can see it becomes really high contrast and just doesn't look natural, at least to my eye. So let's back that off also to about 5. Click on OK. So now we've got a fairly nice looking Crescent nebula where we've been able to emphasize some of the outer areas of the nebula up here. You'll notice that the thing I called out earlier, which is some of the artifacts that exist behind these stars. And what I mean by that, let me zoom in. So I'm using my mouse wheel to zoom in, move around, go down. And you see this kind of artifact around here. So there's a number of ways you can address that. One is a little bit, in my mind, not really the right way to do processing. So what I mean by that is if I go to the layer 1 here and hide it, some people may say, well, look, can I not just copy some of this part of the image over to here to kind of hide this weird artifact? Well, look, really what you're doing now is you're now inventing, you're hallucinating over the image and you're inventing stuff that's not really there. Honestly, for me, I just leave it like it is and then just sort of regard that as kind of like star glow around the star. So it's just something to bear in mind as you learn your processing steps and experiences. And so now what we can do is we can go ahead and we go to layer and we can merge down, bring everything together. You can then export that as a JPEG or TIFF, whatever you want to do. So hopefully this gives you just a few ideas on processing your images of the Crescent Nebula. As I say, there's many options you can choose to do this. You're not locked into StarXTerminator. You're not locked into Photoshop. But again, I encourage you to play around and see what you come up with. Thank you for your time. Thank you.